Hello students. Today we're going to be taking a look at page 17 through 18 notes. Generally speaking, if I don't finish the notes completely, what I'll possibly be referencing are my past notes from prior years. And I have actually done that in various ways already, using maybe a voice recording as well, or just possibly directing you to the past notes. You saw this past Monday with 5-2 past. Let's take a look. Here's section 5.2, 5.3, because today we're going to be doing section 5.3. And I'm going to bounce back a little bit just to reference just a couple more things to remind everybody of. Solving quadratic equations by factoring. So if you recall, and this is certainly an Algebra 1 skill that you guys spent quite a bit of time on, factoring quadratic equations is a very important thing. You need to know how to factor pretty much any factorable quadratic to the point where you're more easily able to solve. All right, so to write a quadratic equation with roots p and q, we let x minus p, one factor, times x minus q, another factor, equals 0. We can multiply using the FOIL method. And typically what we like to do, though, when we factor is take a quadratic in the form of ax squared plus bx plus c and rewrite it in this particular factored form. But we're going to go in the other direction to start with today, just to kind of warm us up. So write a quadratic equation in standard form with the given roots. So we're going to go from the roots to the factors to the ax squared plus bx plus c equals 0. Okay. So let's take a look. We know that our first value here for the root is 3, and the second value here for the root is -5. So in the context of x minus p times x minus q equals 0, one factor is x minus p, and we literally already know one of them is, well, 3. So x minus 3, and we know the other is -5. So instead of x minus um, -5, we could also say x plus 5. Well, they actually wrote it exactly how I said it, which is more preferred when we start here. So x minus a -5, but yes, eventually it comes back down to x plus 5. Eventually, you'll probably just see a negative and go right to x plus 5. So x minus 3 times x plus 5 equals 0. And then you'll take those two factors. You'll do the FOIL approach. If you remember FOIL, which stands for first, outside, inside, last, will require us to take the first two terms, or the first terms x times x. Those two terms multiplied will yield x squared. Outside would then be what? X times 5, which is 5x. Inside will be -3 times x, so -3x. 5x minus 3x, because those are like terms, those subtract out to give us 2x. And then lastly, -3 times 5, that's just -15. So that's the last. First, outside, inside, last, if you remember from Algebra 1. So x squared plus 2x minus 15 equals 0 is our official quadratic equation. And yes, those two roots, like we've already known from the beginning, were 3 and -5. Now, think of the bigger picture here. What this is going to help us kind of reframe, so to speak, based on what we really already learned in the prior sections, is that we have a quadratic that crosses the x-axis at 3, 0 and -5, 0. I'm going to really make this as kind of generic as I can, just to kind of help you guys understand where we're headed with this. But in fact, 3, 0, like I said, and -1, 2, 3, 4, 5, 0 are our roots. They're also called zeros. They're also called x-intercepts. So I'll use that language off and on in different ways. Part B is similar. It's -7/8 and 1/3. They also, just like on part A, they also show this as x minus a -7/8 or x plus 7/8, x minus 1/3, and then multiply through foiling out, setting it equal to 0. Now, I'm not going to belabor their process, although it's actually just as good as this process, which is, interestingly, I think, a little bit more efficient. So let's pretend for a second that these two set equal to 0, and then in fact kind of well, I will set it equal to 0, but starting from the premise of x equals -7/8 and then x equals 1/3, when you set these respectively equal to 0, think about the goal, right? The goal, if in fact you want 0 isolated, for this first equation, x equals -7/8, multiply both sides by 8. And again, you're trying to get it set equal to 0, so simply what? Add 7. Typically, we want to solve for x, but we're going backwards here, solving such that it's set equal to 0. In a similar manner, I need more room here. In a similar manner, we'll take x equals 1/3. Again, trying to set it equal to 0, we'll multiply both sides by 3. Subtract 1, and that's nice, such that, well, 3x minus 1 equals 0. Well, these two now will pack x minus p and x minus q, although there is not a leading coefficient, so to speak, of 1 on either of these, it's much easier to FOIL 8x plus 7, 3x minus 1 than it is, as you saw what they did. I'm leaving it in fraction form. Certainly you could FOIL first, outside, inside, last, and get a quadratic with fractions. And yes, it simplifies down to the answer that you see. But my little kind of sidestep here is a little bit more efficient, and I'll show you why. You won't have any fractions, really. That's the bottom line. So first, outside, inside, last. Let's take a look. 8x times 3x squared. Outside is -8x. Inside is 21x. And then last is -7. Outside, inside, those two are going to add because they're like terms to 13x. So the final answer is in fact justified as such. 24x squared plus 13x minus 7. I won't draw this particular parabola, but it does have in fact x-intercepts or roots of -7/8 and also 1/3. Let's move on. Now we're going to tackle some of these questions, kind of keeping in mind what our homework is for tonight. But let's take a look. I think I'll jump in with number 1, and we're going to bounce around to a couple of others that maybe have some fractions for more practice. So with 3 and -4, we'll start the process with x minus 3. Then x minus, instead of -4, well, minus a negative technically will become plus 4. So that's great. That only, of course, gives us the factors. We're going to FOIL. So if we FOIL, first is x squared, outside 4x, inside -3x, and last 12. With a little bit more manipulation, in other words, we've got to add our like terms of 4x minus 3x, or subtract technically, and we get just 1x, and then that quadratic, don't forget to set it equal to 0, is your official equation. Okay. I'd like to try maybe number 4 next. I'm going to try an even here, which is fine. We'll double check and make sure that we're on path here and on track with relating back to the homework as well. Even if I do some homework problems, that's okay. So -5, we'll think, if this is a parabola, and all of these will be parabolas if we're to take a look at the graph, and again, because it's a negative, we'll say a minus a negative or plus a positive. Now technically, this is an interesting question. Technically, because this is supposed to be a quadratic, they're missing a root. Because they're missing a root, I'm going to add it in as this, -5. Now you're probably thinking, well, why didn't they just write that there? Well, as it turns out, all quadratics must have x to the second power, so I'm going to add in, next to x plus 5, another x plus 5. So we actually call these a repeated root. -5 is repeated, and it makes sense actually if you think about setting x plus 5 equal to 0. That lends itself to -5 as one root, and then the other, well, same thing, -5. So you're still only going to have one answer when it comes down to the graph. The parabola will only touch the x-axis at -5, but the equation, as you see, will unfold like so. So first, outside is 5x, inside is 5x. So there's a pattern. 2 times one of those is just, well, 5x plus 5x. Think about it that way, of course. And then last, of course, 5 times 5, 25. X squared plus 10x plus 25 equals 0. Let's finish up with another problem, but maybe one that has fractions. So let's bounce to, how about number 16? Number 16 is a good question. So like I did in the example up above, where I kind of showed my way of thinking, where instead of maybe foiling x minus a negative 7/8 times x minus 7/2. I'll write this as x equals this, negative 7/8. X equals this, 7/2. Okay, so if we walk through kind of in a sense where we set each respective equation instead of what you see it as equal to 0, multiply this by 8, and then we'll have what? 8x add 7, 8x plus 7 equals 0. The other equation, we multiply both sides by 2, so it looks like this. 2x equals 7, subtract 7, so 2x minus 7 equals 0. This is way easier to FOIL. I almost said factor. We're actually foiling here. Factoring would be taking the quadratic and getting it to look like this particular form, which we'll also talk about down the road. So we got 8x plus 7 times the quantity 2x minus 7. If we FOIL first, outside, inside, last, we've got 8x times 2x, which is 16x squared. We've got 8x times negative 7, which is negative 56x. We've got 7 times 2x, which is 14x. We've got 7 times negative 7, which is negative 49. Don't forget that equals 0. Our final answer should be equal to 0. So if we do the math here, we've got 16x squared. These two like terms, negative 56 plus 14, they'll end up being negative. Do a little bit of math in my head here. We've got 46 minus 4, so negative 42x minus 49. There's your final answer. That is the quadratic in the form that I'm looking for. All right, let's finish up with the last page here. All right, so just to kind of finish things up, the continuation here, as you can see, is to solve an equation by factoring. When you use factoring to solve a quadratic equation, you use the following property. So the zero product property. For any real numbers a and b, if a times b equals 0, then either a can be 0 or b can be 0, or both a and b can be equal to 0. Okay, so now we're going to officially take all that good work we did on the prior page and go back from the quadratic to the actual roots, or zeros, or x-intercepts. All right, solve each by factoring. 3x squared equals 15x. So we're going to take this equation and set it equal to 0. So you can see here this converted to this is yielding this generic standard form. Okay, that gets the process going. So now we think, well, isn't 3x squared and negative 15x divisible by a common factor? They've already subtracted 15x, by the way, to set it equal to 0, but that common factor ends up being 3x. It's also called the GCF. So the GCF of 3x can be divided out or factored out such that you're left with x. And if you factor or divide it out of negative 15x, you're left with negative 5. If that doesn't make sense, or if you're not sure, double check. 3x times x, distribute, that's 3x squared. 3x times negative 5, negative 15x. Because we factored it, we can then set each one equal to 0. So 3x set equal to 0 and x minus 5 set equal to 0. Divide this first equation by 3 to get 0. Add 5 to the second to get 5, and your solution set is just that, 0 and 5. You could also write your solutions just as you see up above as x equals 0 and 5. That's perfectly acceptable too. Part B. Okay, so this is going to take a little bit more thought. 4x squared minus 5x equals 21. First, subtract 21, so you're setting it equal to 0. So here's our two factors, 4x plus 7 and x minus 3. We're going to dig more deeply into factoring. In the next video, I'll kind of extend our ideas on this. But this boils down to, and you can guess and check, or you can use something called split the middle term. In this particular case, 4x times x is 4x squared. We'll kind of guess and check our way through, actually, with the time we have. Outside is 4x times negative 3, so that's negative 12x. Inside is 7, so you got negative 12 plus 7, which is negative 5. 7 times negative 3, which is negative 21. Each factor you can then set equal to 0. Solve, so one is, of course, negative 7/4, and the other is 3. We'll continue more on factoring because this does entail a more systematic approach. This is just the guess and check. Please continue on with the work for today's calendar, on today's calendar too.